Cool. Uh, Thank you again, everyone, for joining. So this is the community call to discuss the recent NX NPM supply chain attack. And we don't really have a fixed agenda for it. We thought, we'll go through the blog post, but would love to have this as a collaborative call. So if you have any unique perspective that you would like to share, please do that in the call. So let me go ahead and share my screen, and please feel free to interrupt us anytime you have questions or comments or something you would like to add. So before we get started with the incident, we can quickly look at like what NX does. So NX is a dev tool company, and they provide solutions for build optimization, scaling CIs, and fixing failed pull requests. As per their website, they are very popular. They're being used by millions of developers every day. Many Fortune 500 companies use their solutions, and so on. And they also have integrations with coding agents, AI, LLM solutions. And as we'll see in the blog post, this was something that the attackers actually leveraged for exploitation, specifically for discovering sensitive files and exfiltrating them. So with this, we can start with a blog post. And starting August 26th at about 10:30 p.m. UTC, the NX NPM package was compromised, and adversaries here basically published a compromised package directly to the NPM registry without making any changes in their GitHub repository. And this compromised NPM package had a data stealing malware, and this malware was designed to steal sensitive credentials such as SSH keys, NPM tokens, GitHub credentials, and so on. And the unique thing about this incident is that this was the first known case where attackers leveraged AI, LLM, CLI tools for discovering sensitive information and exfiltrating them. And the NX team has published an official security advisory, which is actually quite detailed. It talks about all the packages that were compromised, how the attack originated, indicators of compromise, how to recover from this incident, and so on. And on our blog post, we also published a timeline of events. So like I mentioned, at about 10:30 p.m. on August 26th, the first compromised version showed up on the NPM registry account. And then in the next 30 minutes or so, the attackers, or rather in the next couple of hours, the attacker published five more versions, uh, five more compromised versions. So before, a community member detected this incident at 12:30 a.m. UTC, NPM already had, six compromised versions of this package. And even after discovering this incident, the attackers published two more compromised versions. So eventually, there were 8 compromised versions of the NX package on NPM before NPM removed them. And then later, the maintainers realized that a leaked NPM token was used for publishing these compromised packages, and then they revoked the compromised account. As you will see later in the blog post, that public GitHub repositories were used for exfiltrating data. And since these repositories were public, anyone could actually search them on github.com, and anyone could actually download the exfiltrated data. The attackers did not use any encryption mechanism, so it was essentially in plain text. So at 9 a.m. UTC the next day, GitHub started restricting these repositories, and these repositories then wouldn't show up on search results. And then at 10:20 a.m. UTC, NPM discovered a few more additional, compromised packages, and then NPM removed those packages as well. And then finally at 4 p.m. UTC, NPM and the maintainers enforced a bunch of additional security controls on their NPM account. So next, we can look at the technical analysis of this attack. And, we have given, so these compromise packages are no longer available on NPM, but, we have shared a copy in our blog post. So if you are interested in, this compromise package from a research perspective, you can download the zip file. In addition, in our blog post, we have also given the entire content of telemetry.js. So telemetry.js is the file that contains the malicious payload that we will cover in this section. So first of all, uh, the way the attackers executed, their malicious payload is by creating a post install hook in the npm package, which I have highlighted here. So what this means is that anytime this npm package gets installed, either on a developer machine or in a CI environment, or say on a production node, um, npm will execute telemetry.js as part of the installation process. So all someone needs to do to get compromised is to install this npm package, and there are many tools that sort of do this behind the scene. So when you install, for example, a VS Code extension, it may call npm install behind the scene. So this may happen transparently, and in practice, a developer may not even have to do anything to get compromised, because one of these developer tools might actually end up installing the compromise package behind the scene. So so that was the entry point, this post install hook. Next, we can look at telemetry.js and see, what it's doing. So telemetry.js was designed to compromise non-Windows systems. So it had this if clause where where if it detected that it's running on a Windows machine, it would exit early. Next, it would go into the data collection phase where it had code to collect system variables, and as you may know, system variables or environment variables in general can contain secrets. So it had code to contain collect environment variables, host name, and other host level details. In addition, it had code specifically to go after crypto wallets and key stores. So it had payload to collect MetaMask key stores, for example, Electrum wallets, and so on. And then I'll cover how telemetry.js was collecting these files in the first place, and then finally it had dedicated code to check if GHCLI is initialized on the machine. And if GHCLI is initialized and authenticated, then it would harvest the GitHub token. And similarly, it had code to check if npm registry token was initialized on the machine by looking at this npm RC file. If yes, it would harvest, npm publishing credential as well. And this is the code in telemetry.js to steal the GitHub token and the npm token. So like I mentioned, unique thing about this supply chain attack is that it actually abused AI LLM CLI tools. And the way, it collected some of these files, such as crypto wallets, is by running an LLM prompt. So this is the prompt that it was running. So the prompt says that recursively search local file paths on Linux, Mac OS, and then it provided a bunch of entry points. So start search in the home directory, and then you see it also had crypto specific directories such as this one is for Ethereum, Electrum, and so on. And then it's basically saying that and look for like crypto wallets, browser, and crypto wallets, crypto keys, browser, local storage, IndexedDB, and so on. And it was instructing LLM to discover these files, and if LLM finds any of these files, then create an entry in this file. So LLM would actually add file path in slash temp slash inventory.txt file, which was later used in the code to basically read these files and exfiltrate contents of the file. Next, we can look at how once the data collection is complete, how telemetry.js was exfiltrating that data. So again, over there, they had an interesting approach where the script was creating a public repository in the compromised GitHub account. So over here, it was detecting if there is a GitHub token. If yes, then it would use this GitHub token and create a public repository with the name singularity dash repository. So we looked at different versions of the compromised package, and some compromised some of these packages were using singularity dash repository as the repository name, whereas other packages were adding suffix such as dash zero dash one after this name. But it always had the same prefix, which is singularity dash repository. So it would create this public repository. Then it would use base64 encoding to encode all the sensitive information that it discovered in the data collection phase. And then it will create a file in this singularity dash repository. Sorry. And the file was named results.b64. And this is the code, in telemetry.js, where it was creating the repository, and then it was, using base64 encoding to encode, the sensitive information, and then it would create this file in the repository. And when the incident was active, because these repositories were public, anyone could easily, discover these repositories by clicking on this search result. As I mentioned, like later GitHub started hiding these repositories. So you see that there is still one repository that is available, unfortunately. But when the incident was active, we found thousands of these repositories, and again, all these repositories were public. And each of these repositories had one file named results.base b64. And let me actually show you a demo where we'll look at the content of this file. So when we were writing this blog post, we performed end-to-end simulations. So we created a sandbox repository and a sandbox and a test GitHub pat, and then we actually ran this compromised package. I'll cover this simulation exercise later in the presentation. And then it basically created this public repository and results.b64 file with the exfiltrated credential. And let me show you the contents of that file. Let me share my terminal for this. So if you print the content, you see it's it's basically a base64 encoded string. Now if we base64 decode it, so this is the exfiltrated file. And because this workflow ran in a GitHub Actions workflow, and it was the compromised package was installed on a GitHub hosted runner. That runner did not have any of the AI LLM tools, so it could not actually discover any sensitive files. But the environment had a GitHub token, so the environment had GHCLI authenticated and initialized, and you can see here it exfiltrated this GitHub token. And again, we have revoked this token, but when we actually ran this simulation, this GitHub token was active. So we go back to the blog post, and I'll take a quick pause here. Any questions so far?
Yeah, I do have questions, but mostly it's about the defensive control. Maybe I can take it at the last, or if you want, I can ask now itself.
Yeah, because we are also covering, like remediation steps, so maybe we can
Yeah,
actually
maybe
cover
I can
these
ask
questions.
later then. Yeah.
Yeah,
I did have a
that
question.
sounds good.
I did have a question about the extraction portion, which I put in the chat there. I don't know if you want to just review that or I talk about it.
Let me read GSC11. That is correct. So yeah, if GSCLI wasn't installed, or let's say even if it was installed and if it wasn't authenticated,
Mm-hmm.
then it wouldn't extract the GitHub token. And similarly, if none of these AI, LLM, CLI tools were installed, that portion wouldn't work as well.
Got it. Thanks.
So
Yeah.
I guess to summarize, GHCLI and its token was mandatory. Like if that was missing, then this public repository itself would not get created because it was using this GHCLI and the token to create it. In fact, even the token had some validation. Like it could not have been a fine-grained pat. It had to be like either an OAuth token or a classic pat, and so that was absolutely required. But the Claude and or Gemini or Q CLIs were not required for this to work. Like in our simulation, we did not have these installed,
Mm-hmm.
but the GitHub pat was still exfiltrated. Yeah.
Okay. And I noticed also that public repository that it created, GitHub scrubbed that out for the most part. Would that have shown up in GitHub audit logs if they would have scrubbed it? Like, say, if it did occur, and then you're looking at your GitHub audit logs for that, would that
Yeah,
have shown
Yeah.
up? Okay.
it
Yeah,
would
and we have
show up.
covered that here, so you can look at your org audit logs, and users can also look at, their security events by clicking on this URL, and it will show up there that this repository was created.
Okay.
Cool. I think, yeah. So next, we can look at another interesting thing that this malicious payload was doing. It had, code to maintain persistence and sabotage, and the way it was doing is also sort of unique. So it was adding this shutdown command in the bash RC file, which essentially what this means is that anytime you open a new terminal session, it would run the shutdown command, which sort of puzzled me because typically when these incidents happen and attackers want to maintain persistence, they create a reverse shell or they install a command and control agent on the host, and they try to remain in the stealth mode and maintain persistent access. But in this case, the payload is essentially shutting down the machine anytime you open up a new terminal. So it would become very obvious that something is wrong. I still don't know, like why they decided to do this. Maybe, this was to destabilize the system so that you cannot use it for forensics. Also, practically speaking, because this command uses sudo, it would actually prompt the user, before on I would say on most of the machines, it is going to prompt the user for sudo credentials unless, terminal somehow itself is running with sudo credentials. So this command will not run. But again, it had this interesting twist where it was trying to shut down the machine if users create a new terminal session. So next we can look at the simulation exercise that I briefly mentioned. And for this simulation exercise, what we did was we created a GitHub Actions workflow. Let me show you the workflow. And this workflow is running on a GitHub hosted Ubuntu VM, and it's installing this compromise package on the runner VM. And to basically get visibility into runtime events, we are also using StepSecurity Hardened Runner. So StepSecurity Hardened Runner is a purpose-built security agent for CI/CD, and you can think of this like an endpoint detection and response security agent for CI/CD. And it will basically tell us what happened when this particular step was executed. So we can look at the hardener insights by clicking here. So first, let's look at the process event. So when the compromise package was installed, like we saw in package.json file, it had a post install hook which executed telemetry.js, and telemetry.js then had code to check if Claude, Gemini, or Q CLI tools were installed, and that's what we see here. Then it had code to see if GHCLI is initialized and authenticated, which again we see here. And in this case, the GitHub Actions runner VM had the GHCLI authenticated. So then it ran this command, gauth token, to extract the token for exfiltration. And then it also, like we saw, it also had code to see if npm publishing credentials are also stored on the machine, which we see happening here. Next, if you look at the network events, so hardener also observes all the runtime network events, and it maps them to the specific GitHub Actions step that caused it. So we were installing, so we are installing the compromise package in this step, and we see that when this step was called, node process made an outbound connection to api.github.com, and hardener also provides insights into the HTTPS calls. And when it actually made this outbound connection, it actually made two GitHub API calls, again like what we saw in the code. The first API call is post to user/user/repos, which created the singularity dash repository. And the second one is a put call, which was made to create this results.b64 file, which has all the exfiltrated secrets. So again, we can go back to the blog post. And like I mentioned, for research purposes, we have also shared a copy of the compromised package in this GitHub repository, which you can download by clicking on this link. And then we also given the entire content of telemetry.js at the end of the presentation. So that was the technical analysis of telemetry.js. Before I move on to the next section, I know that was a lot of information. We'll take a quick pause, and do we have any questions, any comments, any insights?
So Ashish, this is Sean. I have a question. In terms of this file being downloaded and installed, what basically allows that to happen on, say, a developer machine, for example? Is it just the fact that NPM is checking for any kind of new versions of these packages, and it sees that new version and it just goes and installs that? It's a question I'm getting from my development team.
Yeah, I mean, there could be multiple entry points, right? So one could be a developer explicitly, running npm install command. Let's say they are working on a front end, a node project, which is using this dependency, and they run npm install. That's one way. The other attack vector is, there are a lot of developer tools that actually do this behind the scene without requiring any explicit consent from the user. So like you mentioned, there are a lot of developer tools that periodically check, for example, if a new npm version has been released for a package. If yes, it would install it. So it may, and we actually saw many developers got compromised because of the VS Code NX extension. And this extension was sort of, like doing this operation under certain circumstances, where developers didn't really have to do anything, like all they had to do was open up VS Code or install this uh, extension while the incident was active to get compromised.
And Ashish, if you can maybe scroll to that part in the blog post about the VS extension, because there's a interesting quote there from the maintainer of that extension. So, so if you see here, right, it says, unfortunately, versions 18.63.x of NX console were affected because they executed npx nx latest or npxy latest to check NX versions. So basically, if VS Code, if someone started VS Code and they had this extension already installed, then they would immediately get compromised. So they didn't really have to explicitly run any command just by opening VS Code, and with this extension installed, it would and a lot of developers did get compromised this way. So like this is one example but there could also be other developer tools. Someone had also mentioned something called Comfy UI, which was potentially doing something similar.
Thank you. Yeah, those are good avenues I can go chase down here. So appreciate the diligence and the effort here. Thank you.
And it's another reason why probably not to be on the latest as well because of these things. But these programs update them to the latest, and here we are.
Yeah, in fact, since then, this VS Code extension has been fixed so that it doesn't look for the latest one. But like in general, these extensions or developer tools, they could just be checking for the latest. So this was just one instance, one bug that was fixed.
Okay, so next, we can cover indicators of compromise and how one can discover whether they were compromised or not. So this uh, uh, attacker payload was, like changing file content as we saw in the technical analysis section. So one can look at their bash RC file and see if it has this shutdown command added to it. They can also look at they can also check if if they have inventory.txt or inventory.txt.bak files present in their temp directory. Many of the EDR solutions actually provide these capabilities. So one can write a rule and look for these files across across their fleet. They can also look for outbound network connections to api.github.com, and if they have HTTPS monitoring capabilities, they can also see if these connections were made to create repositories with the prefix singularity dash repository. And finally, as we saw, this repository was public. So one can also check for the presence of these repositories, and if these repositories have a file named results.b64. So I've actually seen a bunch of community members have published useful scripts. For example, where you can go through the list of all enterprise members in your organization, and then look for the presence of this repository in their account, because these repositories are public. You don't need any auth credentials to check for the presence of these repositories. Next, we can cover how this attack originated. What was the source, and the maintainers have actually confirmed the source in their security advisory. So it all started with a vulnerable GitHub Actions workflow. So as you can see in this pull request, a vulnerable workflow was created, and this workflow has two security issues. So first one, you see this workflow is running on pull request target. So it is vulnerable to pawn request because when a workflow runs on pull request target, what that means is that anyone can create a fork of this repository in their GitHub account, introduce some changes in their fork, and then create a pull request in the NX repository. And when that pull request is created, this workflow will get triggered. And this, because this workflow gets triggered on the pull request target event, this workflow will run with elevated context. So this workflow will have an elevated GitHub token, um, which is different from if you were just using pull request. So if you just use pull request, again, when you create a pull request from a fork, it will trigger a workflow run, but that workflow run will only have contents read. It will not have any elevated uh, permissions. Whereas with pull request target, the GitHub token will have elevated permissions. And the typical scenario here is that then once these workflow runs are triggered, you as an attacker try to figure out how you can run your own code in this privileged context and try to steal the GitHub token. And once you get the GitHub token, then you can you get write access to the registry. You can create branches, and we'll cover how that was abused in the second part of the attack. So yeah, so this workflow is vulnerable to pawn request, and you see here in the actions checkout step, the workflow is actually checking out the pull request ref. So what this means is that it will actually check out the source code from the attacker's fork. And then it was, in addition, it was also vulnerable to script injection. So you see here, it's running this script, and it's essentially executing the pull request title as a command, right? And pull request title is again under attacker's control, and they can put whatever they want, and that will get executed as a command here. So this was the original entry point. So they did actually fix this vulnerability shortly, but um, the theory here is that this either this workflow got exploited before the fix was in place, or the fix sorry, but then they did fix it they did make a fix for this issue, but it did not fix all the vulnerabilities. And the attackers essentially used this workflow, and they exfiltrated the GitHub token which had contents right. And using contents right, then they were able to trigger another privileged workflow which actually had the npm publishing credential called publish.yml. And when they triggered that workflow run, they triggered it with this malicious commit. And you see in this malicious commit, the attackers are reading the npm auth token, and then over here they are exfiltrating it to an endpoint, webhook API endpoint that they control. So when they ran publish.yaml with this commit, it basically exfiltrated the npm publishing credential to this endpoint, and then later on they use this npm publishing credential to publish all the compromised packages. So before we go into remediation steps, any questions so far?
Now we can look at the section about the remediation steps. And the first one is just a list of all the different versions that were compromised and how you can check for these versions. And so the first few steps are for your local machine. And then the fourth one is to check for any pull requests where these packages were being added or updated to. So, for example, in this case, this query is for the NX package and one of the compromised versions, and there, there is a org scope, so you can use this and replace this with your own org. And in this case, for example, we can see that this pull request was created by Renovate Pod, and it was set to auto merge. We can also look at another example where if I, let's say, remove this and look for 20.12.0, this is another example where it was updated by renovate and then merged. So you can use this search query and look for pull requests in your organization. Now, if the pull requests were created by a developer, then it is likely that they may have also run the same command on their machine. But if it was created by Dependabot or Renovate, then it would have only run in the CI/CD pipeline. And next, Ashish already shared some information about how to check for your local environment, but you can also review the event, the GitHub audit log for your own account. And if the repository was created, then it should show up here. The next one is to review the AI CLI tools to see, if you have a command history. Now, some of these tools do have an option to enable this command history, and then you can, see if that got executed. And then if any of these steps, confirm that there was a compromise, then this next steps are to remediate, the local machine and also rotate credentials. So, the first few steps are for the local machine, and for if there was a pull request, then, if it was not merged, then one just needs to look at the credentials that might have been exposed. But if it was merged, then it has to be reverted. And in this example, we can see that, once they realize that they've merged a malicious one, then they've reverted it to the earlier one, which was not vulnerable. The next, part is to rotate all these credentials. And it may actually just be, a good practice to rotate all these GitHub personal access tokens and OAuth tokens, even if there is no sign of compromise, just as a best practice. And these are, some of the other keys which if they were on the machine or in the CI/CD pipeline, then they should be rotated. The next one is, like we discussed, this VS Code extension. And if this was installed then and VS Code was started, then most likely it was a compromised scenario. And so then, this has been fixed. So as a best practice, one can just update it to the latest version, the VS Code extension for NX. So those were, some of the steps that you can follow in terms of understanding if your account was compromised and what to do if it was compromised. And then in the next section, we can talk a bit about how our platform helps with, um, these kind of attacks. And since we also saw that the initial attack vector was through GitHub Actions, we can talk about how we help with that kind of attack scenario. So in here, we looked at how you can search for pull requests that had the malicious version. Now, with our platform, a lot of that stuff is automated, so it would just show you any pull requests that were upgrading to or using one of the compromised versions. So this we've set up on a public GitHub org, and here you can see that there was this pull request which was these two pull requests, which were upgrading to NX 21.8.0, which is malicious. So basically maintain a list of compromised NPM packages, then and a pull request has any of those, then this control will show up in here. And then related to this, we are in the process of releasing this cooldown check for NPM packages. In fact, we had started working on this when the previous wave of NPM package compromises happened, because there were a few weeks back, a bunch of them had been compromised because of a phishing campaign. And so what this check basically does is that for any pull request, it looks for the NPM packages that are being upgraded or added. And if any of those versions were released within the last 2 days, and this is configurable, then it would fail the check. And like the reasoning here is that most of these compromised versions get detected within the first couple of days. And like we saw, the projects that actually get compromised through these pull requests are the ones that have merged them within that time frame. So this helps balance the need to keep packages updated with the need to not merge something which was just very recently released. And in here, you can see how this can be configured. So you can, enable this and set up the cooldown period. By default, it is 2 days, but it can be as low as 1 day or as high as 30 days. And I know there was a question, about there not being a lot of information about this, and that's because, this is kind of in beta right now, and that's why we, don't have a lot of information on our documentation about this. The next one is the hardened runner detection. So, like Ashish showed, this hardened runner, it runs in the CI/CD pipeline, and it can monitor for suspicious process events and network events. And if this was being used, it would trigger a detection if there was an outbound call, GitHub API call to a different org than where this particular workflow was running. So if this workflow was running in a GitHub org, but the repo got created in a different one because the path was for a different org, then it would trigger this detection. Plus, you can, from a forensics perspective, also look at what happened. And this is what we use to analyze what this malicious package was doing. And next we can, cover quickly the controls around the spawn request and script injection. So with our platform, you can find out if any of your workflows are vulnerable to a pawn request or a script injection vulnerability. Like in this case, this workflow is also vulnerable to a pawn request because it's using pull request target, and it's then checking out the fork and executing some steps. And then finally, we have a feature called StepSecurity Artifact Monitor, which is more from a publisher perspective. So if you're publishing NPM packages, and this will be extended to other package registries, then it monitors the artifacts that are getting released. And if any artifact is released, when an artifact is released, it basically checks what workflow was supposed to release it and if it ran or not. So if the workflow ran, then it marks it as compliant. But if there was no workflow run, then it would trigger a detection because the release process was not followed. So in this case, for example, this NPM package was published, but there was no associated workflow run in GitHub. In fact, there was no change in the GitHub repository. So, so this would have then triggered a detection that there's a release without a compliant release process being followed. And so that was a quick walkthrough of the remediation steps and how our platform can help with some of this. And let us know if you have any more questions.
So we can say the root cause is like the tools often default to pull latest package version from npm without pinning version or verifying integrity. So that means as soon as the attacker published a malicious update, anyone using the tool configured this way that it get transparently without any consent, right?
So part of it is that some of the tools use the latest version, but part of it is also that if you were just doing development at that time, or like we saw a lot of these pull requests got created by Renovate or Dependabot, then they would also upgrade to the latest. So in that case, the package.json or log file was not using the latest, but the pull request was then upgrading it to the latest, and that will cause this malicious package to get executed.
Okay.
Yeah, and that's where, this cooldown period check kind of helps, because it prevents someone from merging a package version which is very new, which, overall the community hasn't really had time to investigate if it is malicious or not. And most of these compromises, like these NPM package version compromises, get detected within the first couple of days. So if one can just not use packages that are very recently released, then it will reduce the probability of compromise.
So that's from the npm side, right? Given the risk, should we enforce dependency like pinning and integrity checks within our dev environment, like log files, allow deny list, even tools and extensions, so that the latest is never blindly trusted? Do you think that will help?
Yeah, definitely.
Okay. And I think I did have one more question in the beginning. That is in regards to the, given that the malicious telemetry.js leveraged post install hooks, and even we use the LLM CLI tools to recursively search for sensitive files, right? What do you see as the most effective defensive control we could prioritize? Should we focus on developer workstation hardening, or should we learn more on supply chain protections like npm account security or registry scanning? What do you think?
Yeah, I mean, I would say that it's always best to do multiple things and defense in depth. So it's not to just focus on one control. But in terms of scenarios, I think there are two main scenarios. So one is the local development scenario, and the other is the CI/CD scenario. And the thing with CI/CD is that generally, if you are doing deployments through that, then those pipelines will have privileged credentials. And so if these NPM packages can then compromise those privileged credentials, then that can lead to further supply chain attacks. And even though the local development scenario is definitely important, a lot of times those developers, if it is like a good kind of design and architecture, shouldn't have direct access to uh, the cloud and these publishing registries, production registries. So that's like a way to think about it. Like there's these two main scenarios: the developer local development scenario and the CI/CD scenario, and then you can kind of put effort on both sides to secure it.
Okay, that makes sense. Thank you.
Hey, John, I see that you have your hand raised.
Yeah. Hi, Varun. Thanks for the call. Very interesting. On the topic of the cooldown check, do you think there might be a way to create a workflow for GitHub Actions that somehow prevents an update to an npm package before it even runs? So, for example, this cooldown check at the moment, it will prevent the PR from being merged if there's a fresh update because it will fail the build. But what it doesn't do is it doesn't prevent that npm update from running on CI in the first place. So do you think there's any way to do some kind of pre-flight check or a pre-flight workflow that stops it even running on CI in the first place?
Yeah, that's a really good point. And as part of our platform, we do have this capability called workflow run policies, where we can block a workflow from running if certain policies are not met. But as of now, those policies are all related to that workflow file. For example, if it has a runner label which is not approved, but we can certainly look into this scenario that, if there is a associated package.json or a log file, then to block the associated workflow runs.
There is a technical way to implement this, which will only work for self-hosted runners, or even for I'm not sure whether this will work for GitHub hosted runners. Which is, so in self-hosted runners, you can have a universal pre-job hook, and then in that pre-job hook you can check the content. Let's say if it's a depend about PR or a renovate bot PR. So in that pre-job hook you can, and our platform sort of provides this capability, but in that pre-job hook you can check what packages are being upgraded. And let's say, like if a package is being upgraded and it has not been more than 24 hours, you can either block that run or you can fail that run. So that way, you will the packages will not get installed on your CI environment. I'm not sure if there is a way to do this in GitHub Actions, because the dependabot PR, I'm not sure if those work, whether users can control those workflows or not. But for self-hosted runners, because you control the underlying infrastructure, you can certainly do that.
Yeah, I suppose the problem is that if you want to do it on a GitHub hosted runner, you're always relying on your own workflows to put the protection in place. So if there was a malicious package, someone could open a PR where they remove the workflow that's putting the protection in place. Yeah.
Yeah.
I mean, one option would be that if you have, like, let's say that the workflow which is doing the npm install and stuff, that workflow itself has a step which first checks if any of the changes are recent, then it exits out. It's just a little bit of custom code which would have to be added in a bunch of workflows.
Yeah, I suppose that would prevent an automatic update to a malicious package. Yeah, it wouldn't protect you against somebody else opening a PR to do the update. But yeah, it would help prevent like Dependabot or Renovate-bot from doing the update. Yeah.
In fact, Dependabot and RenovateBot also support a cooldown period attribute, where you can set it, and then they would not create a PR if something was, updated within that time.
Oh, that's interesting. I don't think I'd ever paid much attention to that
Yeah.
config option. Oh yeah, there's a cooldown option for Dependabot.
So that actually raised another question. What was that? So you said the cooldown period is 24 to 48 hours, right? Like 2 days. Is it for all upgraded dependencies, or is it only for high risk systems like NPM?
So this cooldown period is more like a concept, and different tools have implemented it. And then for Dependabot and Renovate, I think their configuration you could apply across different ecosystems like NPM and PyPy and Golang and all. So in our platform currently, we are first releasing the support for it for NPM, but then over time we'll add support for more package ecosystem, because essentially the system has to check that this package version, when was it released, and so that information is typically available in some registry or the package metadata. So the check has to be implemented for each type of ecosystem like NPM or PyPy or Java or uh, Golang and so on.
Okay. So you guys already have a plan, like how you want to implement the check inside the GitHub Actions, like any type of blocking merges, or is it gonna be a self-hosted scripts? How is
So
it?
right now, like I had shown, this is what we currently have, where there is a GitHub check, and that check will fail if any of these NPM package versions that are being added are were released within the last 2 days, and this would be configurable. And so this is, what we are currently working on, but this is only for NPM. So in the future, then we would support other ecosystems, like PyPy or even GitHub Actions themselves or Golang and so on.
Okay. This is available, right, in that same blog?
Yeah.
Or this is still not published? Okay. Let me take a look at it. Thank you.
So yeah, there is information about it in the blog, in the remediation section. Okay. So I think we are on you know time, so I guess we can go ahead and close the call. But it was thanks a lot for joining and for the insightful questions and sharing your insights.
Thank you, everyone. Bye.
Yeah. Thank you.
Thank you.